Welcome back to Notes 8.1, 11.1, Part 2. When we left off, we had just talked about the three regular polygons that when you draw their apothem and their radius form special right triangles, and they were a square, an equilateral triangle, and a regular hexagon. So now we're going to go ahead and use that information to find the area of these three figures. So let's begin by drawing our special right triangle. There's my apothem. There's my radius, and apothem, radius, and this is my half side. Now, remember, this one bisects this angle. That's a right angle, which means that it's a 45, 45, 90 right triangle, which means that we have x, x, x radical 2 going on. And the thing that I've been given is I've been given that my apothem is 10. Well, that means that my hypotenuse of my triangle is 10 radical 2. That's my radius. So my radius is 10 radical 2, and that's going to be in meters. Units are going to be very important, so be sure you put units down with each and every one of these, or I'm going to have to take off points. Okay, so my radius is 10 radical 2. If my half side is 10, which it is, because if this is 10, this is 10, then my whole side is going to be 20 meters. My perimeter, if each side is 20 meters, and there are 4 sides, that means my perimeter is going to be 80 meters. Now, I know that you know how to find the area of a square by taking 2 sides and multiplying them together, length times width, but we are going to use the formula, A equals 1/2 AP. So my area equals 1/2 my apothem, which is 10, times my perimeter, which is 80. And 1/2 times 10 is 5, times 80 is 400. So I get 400 meters squared for my area, the exact same thing I would have gotten if I multiplied 20 by 20, but let's just keep that between you and me. And that's as simple as it is to find all of these pieces and the area of this regular polygon. I would like you guys to do it in number 2 and come back when you have your answers and check them. So hit pause now. All right, so you should have gotten an apothem of 6 units, a side length of 12 units, a perimeter of 48 units, and an area of 144 units squared. Did you get that? Good. Let's move on to our next polygon. So the second polygon that has a special right triangle inside of it is an equilateral triangle. And we'll go ahead and draw our apothem and our radius. And this triangle is a 30, 60, 90 right triangle because it bisects this angle. That's a 60-degree angle, so this is my 30-degree angle. And this tells me that my radius is 8. Okay, so if my radius is 8, that's my hypotenuse. My small side is going to be 4, and this side right here will be 4 radical 3. Well, this side that's 4, that's my apothem, so that's 4 meters. If my half side is 4 radical 3, my whole side is 8 radical 3, because I just multiply that by 2. And that means my perimeter, I take that, and since there's 3 sides, I multiply it by 3, and I get 24 radical 3 meters, which means that the area of my triangle is 1/2 my apothem, 4, times my perimeter, 24 radical 3. So I take and I multiply the 1/2 times 4, and I get 2. 2 times 24 is 48, and then I just keep the radical 3. So I get 48 radical 3 meters squared. And that's how we find the area of this triangle. I would like you guys to do it for this triangle. So go ahead and come up with your answers and come back when you want to check them. Hit pause now. All right, so this one got a little complicated because if the perimeter is 24, then the side length is 8, which means the half side is 4. But that is your long leg. So 4 is going to be equal to x radical 3. And then you need to solve this to find your apothem. And when you do that, you get 4 radical 3 over 3, which means that your radius is twice that, so it's 8 radical 3 over 3. So your radius is 8 radical 3 over 3. We already knew what the perimeter was. And when you plug the apothem into the formula for area, you wind up with 16 radical 3 meters squared. If you do not understand that, be sure you ask about it in class. Let's move on to our next regular polygon. Okay, so the final regular polygon that has a special right triangle inside it is a hexagon. And when I draw my apothem and I draw my radius, we have a 30, 60, 90 right triangle, only this time this is the 60-degree angle and this is the 30-degree angle. And I'm told that my side is 10, which means my half side here is going to be 5. And since that's my short leg, my long leg is going to be 5 radical 3, and my hypotenuse is going to be twice my short leg, so it is 10. The interesting thing about a hexagon is that the side length and the radius are always the same. It's just a side note. So my radius is 10 meters. My apothem is 5 radical 3 meters. My perimeter, there's 6 sides, so that gives me 60 meters, which means that my area is 1/2 of 5 radical 3 times 60. 1/2 of 60 is 30. 30 times 5 is 150, and then we tack on the radical 3. So 150 radical 3 meters squared is the answer for my area. All right, I would like you to go ahead and do the second one. So please come back when you have all of the answers. Hit pause now. All right, so you should have gotten a side length of 12 meters, an apothem of 6 radical 3 meters, a perimeter of 72 meters, and an area of 216 radical 3 meters squared. This concludes our notes for today. Please be sure to ask about any questions that you still have in class tomorrow, and please be sure to do the notes check. Thanks.